Okay, so we should start now. Can you hear me?
Yes, sir.
Okay. So the part that I will teach today, that is the memory management and page replacement technique will be taught here. Just a minute. One question will be coming in the examination from memory management, I mean from the page replacement technique that I am telling you now. Can you see the screen?
Yes, sir.
Okay. So this part, this valid bit, invalid bit, this thing I have told. Okay, segmentation also I have told. Then I am coming to the part that is the virtual memory. Okay, so in this virtual memory we have the concept of the page replacement algorithms. Okay, so first of all you can see that in the memory, if you keep something, some program or data, that means you're just keeping that one for the execution. Okay, so every code that needs to be executed should be stored in the memory. Okay, like I told you that any program, any operating system, I mean the operating system first, then some other programs that will be kept in the memory for its execution. Okay, but the entire program is not used. Okay, means that there are some part of the program like the error code, okay, the unusual routines and the large data structures that may not be used. Okay, so you have studied about the data structure and you know what is the use of this data structure. Okay, like linked list, stack, queue, and the tree. These things. So these are used in the operating system, also in the memory management part, in the CPU management part, in these things. Okay. So every topic you have studied in different subject like data structure, programming, your DBMS, operating system you are studying right now. So they are all are related and they are used in the computers working, internal working. Okay. Now, what is happening here that some of the part of the program, okay, like the unusual routines that may not be used, okay, like error code, these may not be used, okay. So the entire program code is not needed at the same time. This thing happens, okay. Only the important part will be taken, or the program main function will be written, will be taken for execution, and the remaining part, the part that is not required, that will not be needed. Okay. Now, the program that is no longer constrained by limits of physical memory, and the program that could be larger than the physical memory. Okay, so you think about a program, about a game, suppose that your GTA 5, suppose, or any other game like Matrix, okay, this type of games. So these games are actually very higher size game. Okay, So you are not able to take them in the physical memory, or you are not able to accommodate them in the physical memory. For that, what will you do? So for that, you are going to the concept of the virtual memory, and the virtual memory is also divided into uh, different pages, like page 0, page 1, page 2, in this way. As you have seen in case of the logical memory also, we have divided the logical memory into number of pages, and the physical memory was actually divided into number of frames. So here in the virtual memory, we are dividing v number of pages over here, okay, and that is mapped in the memory map, where each pages of the virtual memory is mapped to the physical memory, okay. Now this physical memory is the small memory, because you are not able to fit a particular process within the physical memory, okay, because of the insufficiency of the physical memory, okay. And the virtual memory is actually large size, and that are able to keep data within. That means if the physical memory is insufficient, then we are going to the virtual memory, that is actually taken from the secondary storage generally, okay. And this this virtual memory can take the entire data, okay, or the process also for the execution. Now so how this thing happens, how the work happens? First of all, suppose one process, that is P1, that came for execution, okay. Now in this process, suppose we have n number of pages, okay, and we have n number of frames. So n number of pages, n number of frames. First, the condition that should be checked here, that the page number should either be so that means here actually basically n number of page means n number of frames is required, because you have to keep the pages, like page 0, page 1, page 2, like page n is here. So you should have n number of frames in the physical memory, so that you can keep the pages in that particular location, okay. So n number of pages is determining that n number of frames should also be there, okay, and you are going to allocate n frames within for the process P1. So you have to create the page table for the P1. That means you are going to create a page table. That page table, this page table. This page table is containing that which page is actually contained in which memory location. I mean the which frame location. Okay, that should be maintained here. Now, in the virtual memory, actually, the separation of the user logical memory is from the physical memory. That means here physical memory means the main memory, and the logical memory means the memory that is actually containing the addresses that are generated by the CPU, okay. Now the extremely large space that is available here, okay, that should be that should be for the programmer, and so we have to concentrate on the problem. That so that think that about the extremely large logical space is there, because of that, because the virtual memories are containing the logical, I mean logical addresses, okay. So now this is extremely large, whereas the physical memory is extremely low, okay. Now we have to think, or we have to concentrate on the problem, that is the virtual memory. Why don't people join previously? The virtual memory can take the load of the physical memory. This thing should be there, and this is separate from the physical memory. Virtual memory is not attached to the physical memory. Generally, we do this thing that virtual memory we take from the secondary storage, and for the execution of the processes. Okay. Now, this virtual memory can be implemented